Hello, class. Um, Unfortunately, I'm a bit sick today, so I can't be there in class with you. Luckily, I should be able to put this on Schoology, so you should be able to watch it and have access to it and be able to do a little bit of practice this way. I understand I won't be able to answer questions as much or help review as much as I could be if I was in class with you. But luckily, I'll be there tomorrow. We'll be able to talk about some things and catch up. We won't have our assessment tomorrow just because the craziness of this week and everything that's going on. Um, so, but we'll be able to do a quick practice together, and then there should be a worksheet on Schoology as well. You'll want to do the problems on just a separate sheet of paper because you won't be able to or you won't be able to access the worksheet or you won't be able to um, print the worksheet, so you won't have a physical copy. But you can copy the problems down on another sheet of paper, or just as if I had the problems on the board or something like that. But that shouldn't be an issue. So we're going to get started with this lesson. I apologize. I'm using a mouse, so my writing might be a little worse than normal. I know it's pretty bad normally, but with this mouse, I'm still getting used to it. So I apologize for that. If you have any questions, just please email me. So on Tuesday, we were talking about geometric sequences. Um, so geometric sequences, we had two types of sequences. We have arithmetic sequences and geometric sequences. So arithmetic sequences is when we were increasing by a constant difference. So that was like adding 3 every time or subtracting by 2. We had those patterns that were consistent every single time. Geometric sequences that we talked about on Tuesday, these were different because rather than having a consistent pattern or consistent increase, it was a ratio. You were multiplying by a specific number every time or a specific ratio every time. And the way we found that ratio was we did your one term divided by the term previous of it. And that's how we found that ratio. So we had a rule for geometric sequences. Let's see if I can type this in here. Change the font a little bit smaller. So our rule for our geometric sequences was a sub k, put in the little sub letters, so a sub k, this was equal to, this was equal to a sub 1. A sub 1 was always your very first term of your sequence, times, I don't want to put x in there, I'm going to put a little dot. I'll leave a space for a dot. So that's going to be times r. R was that ratio, whatever that number was that we were always multiplying by. It could be 4, could be 18, could be 1/2, we don't know. It was that number, that ratio that you're constantly multiplying. And this was always raised to the power of k minus 1. And k, once again, was just your term number. It's just your first term, second term, third term, whatever it was, you put that number in for k. And so put our little dot in there. All right, so a sub 1 times r to the k minus 1. This was our rule for our geometric sequence. So using this idea, remembering that r is equal to your first or a term divided by its previous term, see if you can figure out what r is, and then see if you can figure out also what your first term is, and then write the rule for this arithmetic sequence. So what is a sub k equal to? Once again, sorry for the terrible writing. But take a moment, see if you can find that. It shouldn't take you too long to find your R and your A. All right, so we're back. Our first term we saw was 8, so our A1 should be 8 in our A sub k rule. If we look and we do our R is previous term divided by the term before it, we can take 12 divided by 8, and that should give us 1.5, or 27 divided by 18, 1.5. But it's always going to be multiplying by 1.5 every time. So 1.5 or 1.5 or 3/2, whatever value you got for that, whatever equivalent value you got, that should be your R, and that raised to the power of k minus 1. Once again, that k minus 1 is always in there. So with this problem, we're not solving for anything, we're just looking for that rule. Sorry, I'm going to erase that because it looks terrible. This was a sub k. Sub k. And that's what we got for our work. So hopefully that seems pretty familiar from Tuesday. Today is just going to be a bit of practice, just reviewing what we talked about on Tuesday. Quick, simple stuff, stuff that we already know. That way you can practice it on this worksheet. So that's how we found our rule, or found our rule. Take that first term, figure out what the R is, plug that in there. Sorry about that. Ugh. All right. So write the rule for the sequence and then find its 10th term. So similar idea, we first need to figure out what the rule is. So using that same step we just did in that last problem, see if you can figure out what's my a sub 1, what's my r, find your rule. So I'll give you a quick moment to do that. All right, hopefully you're able to pause the video and get that. So we're back. We have a sub k equals 640, our very first term, times 0.5, sorry, times 0.5 raised to the k minus 1. 0.5, once again, that's the same as 1/2 or dividing by 2. So you might have noticed, yeah, we're cutting in half every time. It's getting smaller by a half. So take a previous term, so 320 in this case, and divide it by the term before it, so 640, and you get 0.5 or 1/2, whatever your calculator spits out you, depending on whether it's in a fraction or a decimal. And that is our rule. Now, we had two parts to this question. The second part of this question was find the 10th term. So 10th term, all we have to do is figure out what a sub 10 equals. So we're going to use that rule, and we're just going to plug 10 into this function. My goodness, this is terrible. 640 times 0.5. Once again, we're just plugging 10 into this function, or into this sequence. So all you have to do is figure out what 0.5 raised to the 10 minus 1 is times 640. You can plug that in your calculator pretty quickly, and that should give you your sequence. So we can do 640 times 0.5, raise that to the power of 10 minus 1, and this is all equal to 1.25, and that would be the 10th term of your sequence. If you don't have a calculator, there's a couple blue ones up by my desk that you can grab. If you need to, go or pause your video and go to Mrs. Ruprecht's room, and you can grab one from there as well, just like all of the yellow calculators. So if you need a calculator, you can do that really quick. Let me pause this video to do something. I'll be right back. Alright, so yeah, we have 1.25. Hopefully you're able to get a calculator if you don't have one, because you'll want one. Alright, so if a sub 1 equals 13, and a sub 9 equals, whoo, that's a big number, 5,078,125, find the rule of this sequence. So once again, exponential functions and geometric sequences, they're multiplying. You increase very, very quickly, very, very fast, and get very large numbers. So we want to find the rule of this sequence. So we did a problem similar to this at the end on Tuesday, but we kind of ran out of time. So let's try this one, and we'll talk about it. So we first need to find, we're looking for the rule of this sequence. So once again, we need to figure out what this is. What is this a sub k part of our function? Just paste that on there. All right. So we need to fill in these values. We need to figure out what this rule is. Now, looking through this and looking at what we know, we only know one part. The only thing we know is what a sub 1 equals. So a sub 1. Oh, I'm sorry. I clicked to the wrong slide. Let me cut that. Here we are. Okay. So the only thing we know so far is a sub 1 is equal to 13. That's the only part that we know so far. Alright, so we can rewrite this, except we can rewrite it with 13 in there. So let's see if I can copy this one more time. And then let's change it to put 13 here. That's the only piece we know so far. Let's see if I can put a multiplier sign here. No. Alright, I'm going to put an X in there. Just remember that this X means multiply. Actually, I don't like the X. I'm just going to put a dot. Alright, there's our dot. Alright. So we have 13 times r to equal raised to the power of k minus 1. Now, we still need to figure out what r is for this sequence. So in order to find r, we're going to have to do a little finagling. We're going to have to do a little work. The only other piece of information that we have not used yet in this problem is a sub 9 equals 5,700,000. 78,125. That big number with this huge thing. So, but we know the ninth term of our sequence is this number. So if we plug 9 in for our k, that makes it our ninth term. We know it will be equal to this number. And then we will get rid of our other variable and we'll only have k to solve for. So we can solve for k, we just have to plug in this information for our k. Or we can solve for our r. So we're going to do 5,078,000. I don't know why I picked this number. This is terrible. 5,078,125. This is equal to what we know is 13 times r, and then we know this is the ninth term of our sequence, so we can do 9 minus 1. So all I did was I changed 9, or k to 9, and so I know a sub 9 equals this number, so I was able to plug that in, and I just changed this k to 9. Now we can simplify a little bit here. So 9 minus 1, that's the same as just 8. So I'm going to take this and I'm going to re-erase it. And I'm going to plug in 8 right there, just because I know that's simple math that we can all agree with. All right. Now, in order to solve this, I need to get r by itself. So the first thing I'm going to do is I'm going to get rid of this coefficient. So I'm going to get rid of this 13. So we're going to divide by 13. So we'll divide by 13. And we'll have to take this big long number and divide by 13. So this is why we enjoy having our calculator. So you can do that really quick. Your 5,078,125 divided by 13. Alright, and that leaves us with, still a pretty large number, but something we can work with. That leaves us with 390,625. So 390,625. And this is equal to, if you look what we had left, our 13's canceled out. So all we have left is r raised to the 8th power. Once again, sorry for these ugly writings. The mouse is not my friend. Alright, so we have this bit of information so far. From here, we need to solve for r. So we need to get rid of that exponent. Now, something that we might have to remember back from 8th grade, is probably when we talked about this, is what is an inverse operation of an exponent? How do you get rid of these exponents? Now, what we've talked about, or what you probably remember, is if you have an, say, we have this number x squared. And x squared equals some number like 64. So if you need to get rid of that square, our inverse operation of an exponent of 2 is we take the square root. And you take the square root of both of those numbers, and that cancels this out. So that gives us x equals whatever the square root of 64 is, which is just 8 in this case. So that's how we get rid of squares. Now we're going to do the same, we're going to take the same idea, except we're going to change it. Let's get rid of this. Alright, so rather than having x to the square, what if we had x to the 4th? How would we get rid of that? Or sorry, let's not do 4th yet. Let's do 3. So if you were to get rid of x to the 3rd. Now, it's the same idea, getting rid of this. Like, so in order to get rid of a square, we take the square root. In order to get rid of this 3rd, we do something called a 3rd root, or a cube root, because raising to the 3rd is called cubed. So in order to get rid of this 3rd, we do something called a 3rd root. So it's like a square root, it'll have this little 3 on the outside. And that's the inverse operation of raising something to the 3rd. So you take 64 and you put this little 3 on the outside. Now the thing is, we need our calculators to be able to find these numbers. So if you have your calculator in front of you, I'll give you a moment to grab it, and you look at, talking about the graphing calculators, at least the yellow ones. If you have one of the other calculators, you'll have a similar symbol, but it might be in a different location. So you might have, if you can't find it, you'll have to ask me about that tomorrow. But looking at the yellow calculator, if you look on your calculator, if you look from the second, you go down to alpha, math, and then there's x to the -1, and then there's x to squared, or x to the power of 2. Right above that in blue is your square button. So that's if you ever need to take your square root. Oh man, give me one moment. What am I doing? Sorry. Give me one moment to fix something. All right. So there's that little button above our square root or square button. That's our square root. So if you ever need to take the square root, that's where we can find that. For something with this cubed root though, so we have this 3 on the outside. For taking a third root, what you can do is looking on your calculator, there's the button that says math. So you can hit math, and it should say frac dec 3 root with parentheses, and then number 5 is x with a square root sign. So if you're taking the third root, you can do number 4, where it's the 3 and then the square root sign with the parentheses, and then you can hit that button, hit enter, and it'll give you a little square root with a 3 on the outside, and it'll have like a blinking open space, and you can type in 64 or whatever number you need to put in there. And if we were to take the third root, that would give us 4 as our answer. Now, thing is, so this works for every type of root. So we just did a third root, but in this we have raised to the exponent of 8. So we need to take what is called an 8th root. So we're going to take the 8th root of both of these numbers. So it's going to look like a square root, except it's going to have that 8 on the outside. So it means what number multiplied by itself 8 times is equal to this number. And that's our goal to figure out. So if we take the 8th root, our 8 exponent cancel out. So we're just left with r. But we need to find the 8th root of this number. So what you can do in your calculator is you can hit math. And it'll take you to that frac dec thing we were just at. If you go down to number 5, the one that has the x square root, hit enter. It depending on your calculator, it might say answer square root. It takes the number from before. So if it says answer square root and then has a little blank, scroll to the left over till you get answer, and we're going to put 8 on the outside of that number. So we have 8 square root and then it has a little flashing blank spot. Inside that blank spot, you're going to put your 390625. So we should on our calculator have something that looks like this. Well, pretty much the same thing we have, just above. It should, in your calculator, you should have something that looks like this. You're able to put in the 8 in front of the square root, and it should be like a little sub 8, or it's like it's a small 8. It's not a full number, and then it's 390625, and then we can hit enter, and that should give us 5. Ooh. And so 5 is your answer. So we have r equaling 5. And so now that we have r, we solved it, we have our full value, so we know a sub k, that's an a, I promise. This is equal to our a1, which was 13, times 5 raised to the k minus 1. Okay, so that might seem like a lot, at least on the explanation part, but actually, if you think about it, our steps were very simple. All we had to do was we knew we were filling in this a sub k equals a1 times r raised to the k minus 1. a1 we know is 13, so we plugged in 13, so we have that. Then we just had to solve for r. We used our other information, the other term we knew, a sub 9. So we plugged that number in for a sub k, and we turned the k into 9. We knew 9 minus 1 was 8, so we just put 8 right here. And then we had to divide by our a sub 1. So we divided by 13, and we got the 390,625 was equal to r sub 8, or r raised to the power of 8. And so we took the 8th root of both of these sides to cancel out that exponent to the 8th, and we got r equaling 5, plug it in, and that is our final solution. So it might seem like a lot, but really, once you get those steps down, it's fairly simple. It's just really understanding what the steps are. Stop. Sorry. I have an annoying critter next to me. Alright, so here we are. So if a sub 1 equals 6, a sub 5 equals 486. Find the rule of this sequence. So think back to what we just did on that last problem. See if we can mimic these steps one more time. So take a moment, see how far you can get on your own. Pause the video. If you need help, unpause the video and I'll do it together. Alright, so doing it together, we know we have a sub k. If I can type this on, actually I still might have this. So a sub k equals a sub 1, these subs are terrible, times r raised to the power of k minus 1. We know we need to fill in all of this to get our rule. Let me get rid of this real quick. Okay, there we go. Alright, so we need to fill in those values. So once again, we know a sub 1. That's one piece of information we actually know. So a sub 1 is 6. So we're going to just take that whole thing, copy it down. Sorry, I got rid of it. So we're going to take that whole thing, copy it down, and we are just going to change a sub 1 to 6. So this becomes 6 now. Alright, sorry about that. Okay, so I'm back. So we have 6 equals r times k minus 1. So once again, we need to solve for r. We need to figure out what that r is. So the only other piece of information we have is a sub 5 equals 486. So we know if we plug in the fifth term for k, if we plug in 5 for k, we know it has to be equal to, whatever that is equal to is 486. So 486, if I can get this, is equal to 6 times r raised to the 5 minus 1. Same thing we did on the last problem. 5 minus 1, we know what that is. 5 minus 1 is just 4, hopefully. Sorry, I'm getting slow. Alright, so 486 equals 6 times r to the 4th. Now, in order to solve for r, we have to get rid of the number in front of us, so we're going to divide by that 6, divide by 6. So we'll have to take 486 divided by 6, and that should give us, if you use your calculator, 486 divided by 6 gives you 81. So we have 81, oh, that's ugly. 81 equals r to the 4th. Alright, so we have r to the 4th, 81. From here, now we just have to do that thing that crazy thing we did on the last one. If we're raising to the power of 4th, we are going to take the 4th root. So we're taking that square root, except it's going to have that special 4 on the outside. So that once again, this represents what number times itself 4 times is 81. And that's what we're going to figure out. So on your calculator, you're going to hit math once again. Go down to number 5, where it's the x radical or the x root. It's probably going to say answer square root, and it's going to have the answer from the last one. We're going to put 4 on the outside. So 4 where that answer part is, depending on whether your calculator, 4 where that blank is on the outside. We're going to put 81 inside the radical, and then that gives us our answer of 3. And so r equals 3. And so once again, our final part is 3. I'm sorry, I'm doing the wrong thing. So our final solution is, let me try to copy this one more time. A sub k is equal to a1, which we told was 6, times r, which we determined was 3, raised to the k minus 1. And that is your final solution. That is your final answer, or the final rule for this sequence. All right, hopefully you were able to get through all this. Hopefully you were able to get some practice, and hopefully I sound kind of normal on this thing, and hopefully I actually make sense what I'm talking about. If you have questions, please email me or let me know tomorrow. There should be some practice on Schoology that you can work on as well that I want you to do with the rest of your time. You might not get through all of it, and that's okay, but if you have trouble, email me or circle a question and tell me about it tomorrow, and we can work on it together tomorrow. There will not be there won't be a skill quiz, or there won't be an assessment tomorrow. I can't remember if I said that at the beginning today or not. But get started on your practice with the rest of your time, and I will see you hopefully tomorrow again. Thank you.